In this section, we'll be dealing with percent of change. It seems like everywhere in the world we see words like sales and savings and such percent off. We can use the percent of change formula to calculate changes in quantities such as price or temperature, things like that. There's a percent of change equation out there, but I like to use a simplified version. And while I won't bore you with the simplification, it looks something like this. We have percent change equals actual change. If we're talking about the percent change in price, we'd have the actual change in price divided by the original price, or the original amount. Okay, so there's keywords that we can identify here, so let's look at a few examples. Let's say we have a $300 TV. A $300 TV. And this $300 TV is on sale for 15% off. 15% off. And we want to know, what is the sale price of the TV? What is the sale price? So we have a $300 TV that's 15% off, and we want to know what the sale price is. This is the percent of change formula is actually pretty useful to find this. So let's identify a few of the parts. Percent of change, we see a percent sign right here. So just like in the percent equation in the previous videos, we can identify the percent as the percent of change. It's the only where in our equation that we see percent. So 15% off is going to be our percent change. Now notice it's 15% off. So what we're going to do here when we're converting it to a decimal is we're going to use a negative 0.15 because we're actually taking off 15%. So we're going to have a minus here. Make sure we don't forget that because that's very important when we're finding our answer. Now we have the actual change divided by the original amount. Well, here we have the original amount. So let's go ahead and put that in. It's a $300 TV. That's the original amount of it. We want to know the sales price. So what we're going to have to find is the actual change in the price. So we're going to define our variable x as the actual change. And this is what we want to find, the actual change. So x in the numerator, and this is our percent of change equation. So all we have to do is simply solve for x. Okay, we have an equation to solve, so what we can do is we have x over 300. I like having our variable on the left side. We want to get everything else on the right side. Minus 0.15. We can isolate x by multiplying by the reciprocal. The reciprocal of 300 over 1 is 1 over 300, excuse me, is 300 over 1. It's the reciprocal. We have to do the same thing on both sides, multiplying by 300. These two terms cancel, and we're left with x by itself on the left side, and we're multiplying minus 0.15 times 300, which gives us a minus 45. So the actual change in the price is minus $45. Now, notice this isn't what we're being asked for. We're being asked for the sale price. We find the sale price by subtracting the actual change in price and the original amount. So we find the sale price by subtracting 300 minus 45. The price went down $45, so the sales price is actually $255. And that's our answer. So the sale price, the actual change decreased $45, so we subtract the original price and the sale price, or we can subtract that from the original price, the actual change from the original price to get the sale price. Okay, it's kind of intuitive, but we always want to be sure that we're answering the question. We're not being asked the actual change, we're being asked the sales price. So we subtract the actual change from the original amount. Okay, let's do another one. Let's say Peter earns a salary of $40,000. $40,000. He receives a 10% raise. He gets a 10% raise. We want to know, what is his new salary? Okay, Well, you can see why the percent of change would be useful here, because this is actually kind of important. If you get a 10% raise or any raise, you want to know, well, what's going to be my new salary? So let's plug in to our equation. Now here we have a percent sign, so that tells us that we have a percent change. Now we have a 10% raise, so we're actually it's gonna be positive. It's gonna have a positive 0.1. Unlike up here when we're dealing with 15% off, we were subtracting a certain percent of change. Here we're going to be adding it to our salary. So we have 0.1 equals the actual change over the original amount. Now here we don't know the actual change, we only know the original amount. His original salary was $40,000. So again, we're going to let X equal our actual change. Okay, that's the variable that we need to find to help calculate our new salary. So here's our equation. Okay, so let's go ahead and solve for our X. We can multiply both sides by 40,000. And do the same thing over here. 40,000, squeeze that in up here. Okay, hope that didn't confuse you. We're multiplying both sides by 40,000. These two terms cancel. We're left with X equals 40,000 times 0.1, and that'll give us 4,000. 10% of 40,000 is $4,000. Now this is our actual change. It's a plus 4,000. Up here it was a minus 45. Here we're adding $4,000 to our salary. Now notice we're not being asked what the change was. We're being asked what the new salary is. So we're going to add 4,000 to our original salary. So 40,000 plus 4,000, which is the actual change, will give us our new salary of $44,000. So Peter's new salary is $44,000 after a 10% raise. Okay, so what did we learn here? We're looking at applications, real-world applications, using a percent of change formula. This is very useful, especially when dealing with price, because we see it so much in real life. So let's get familiar with this. We'll do several more examples. I'll see you in the next video.